Oh, it is now. All right. Thank you very much for being here. Again, let me start with thank you for coming over, spending some time with us, building the community, helping out, making .NET open source rock. You rock as well. Again, thank you very much. And that's about .NET Fringe. So what is this talk about? Lucene.NET, just to get a bit of idea of the crowd. How many of you guys are using Lucene.NET? Wow. How many of you have heard of Lucene.NET but haven't used it? How many of you haven't heard of Lucene.NET? Okay, so you see I have a lot of range to cover here, and that's what I'll try to do. So I'll introduce Lucene, talk a bit about Lucene.NET, show you some code, and then talk about where we are today, where we are headed, and hopefully all of you guys can take something back home. Now, about me, I've been involved in Lucene.NET for a couple of years now. I think it's 2 or 3 years. I've been involved in Lucene and stage technologies for many years now. Back in the day, it was C Lucene, and I've been working with Java Lucene project as well. And I've also done some other open source contributions. Some of you may have heard of Nupdate. Who's using Nupdate? Nobody? So I did hear some stories in this conference about people using that. It's basically application, desktop application update framework. And I haven't touched it for 2 or 3 years, and here in the conference I suddenly see people who are still using it, which is kind of cool. So yay, open source.net. And let's talk about Lucene.NET. So I've been involved in Lucene.NET again for a couple of years now. Today I'm a committer and the PMC member, which Troy is also a PMC member. And let's understand what Lucene really is. So Lucene is a software project. It's a Java-based. It's written originally in Java, and its all intention is to allow you to search. What search is? It's basically like we had back in the days when we were using books, reading books, and you would want to find which page talked about, for example, Pablo Picasso. You would have opened the book in the back end of the book, and you look up the words in the index, and then you go to the page numbers that the index would send you, and you would be assured that Pablo Picasso is mentioned on pages 11, 12, 13, etc., etc. So that's basically what Lucene is. Lucene is some sort of a mechanism that lets you take data and index that in order to allow you to search on that, to find data quickly from large pools of text. Now, because we're dealing with text, it's not just one simple value matches. It now allows you to do full text searches. Full text search is basically the ability to take a sentence, a whole bunch of text, break it down into words, and then index those words. So that thing that you get in the end is called the inverted index. And it's called inverted because basically we are going to take a sentence or a document or a text stream and do some sort of inversion process and have that in the index. So if us as human beings are looking at text as a document, field, and term level, so each of those 6 lines is a document, and for example, here we have only one field because we only have one stream of text in each document, and then in each field we are going to have multiple terms, and that's how us human beings are reading text. The inversion process inverts that. So we end up having one big index, and that index starts with a term. I can look up terms really quickly because it's sorted alphabetically or lexicographically. And then once I found the term that I'm looking for, that index is going to point me at the documents and the fields that term appears in. And that's how I can actually go now and search for one word out of this whole stream of text and find it really quickly. Because instead of scanning document by document to find this word, I can now go and look at the index, find that word very efficiently, very quickly, mostly completely in memory, and then find this word and know which documents have that word. Now, as you can notice here, if this is my sort of dictionary, sort of my index, so you can see that some terms can be collapsed, right? So if I'm looking for keep, keeper, and keeps, I might just as well merge them into one record. And if I don't, I basically will not be able to find them. Or sleep and sleeps, another example. There is another prime example of stuff that I can do with the terms that I'm putting in the dictionary. For example, words that are very frequent in the language. They are called oftentimes stop words. So sometimes I would want to remove stop words as well. Do all those kinds of things, highly language dependent, highly corpus dependent, but I need to have this control over how I translate my documents into this index, into this alphabetically sorted table that I can search on and have this very efficient search experience. So that's basically what Lucene is. Lucene gives you the ability to take a stream of text, parse it, not really parse it, but basically tokenize that, and then manipulate the tokens in certain ways, change their text and do all sorts of things, and then create this index. Once you have this index, Lucene allows you to search on that index. So you can issue queries, full text search queries for mostly, and then get results back, and then I can basically do a Google-like search on any type of data that I have in my system. Lucene is not only about, sorry about that, PowerPoint doesn't like having big slides. So Lucene is not only about full text search. Obviously, it was invented for full text search. Basically, it's just an implementation of well-known ways of doing full text search, just like the one I explained. And then it involves also to supporting many languages, many types of texts, if you will. So how do I treat email addresses? How do I treat URLs, IP addresses, those kind of stuff? Everything basically has a way of being handled within Lucene. And again, language support, the way I'm going to treat Japanese is different than the way I'm going to treat English, and is very different from the way I'm going to treat Hebrew. So all of that needs to be supported in a way, and Lucene gives you that. And then how do you deal with spelling errors? If your user type he typed Danny with an I and not a Y, you want to be able to somehow provide him results still. So fuzzy search, regex searches, all of that is again supported. But search is not only about full text search. You can search for example, for geospatial locations. So if the image at the top here shows you a very typical geographical search. Whenever I want to search for a restaurant which is couple of kilometers or meters or miles apart from me, and that's basically what geospatial search gives you. It has a way of translating that data, that geographical data, into things that Lucene can understand, and I'll show you in just a second how it works, just to give you an idea. Other things that Lucene gives you is, because it's a search engine, it also evolved to providing you very fast, very efficient searches as you type capabilities, and that's again in core Lucene today as well. You guys also know probably about faceted search, Elasticsearch. If you know Elasticsearch, it took it to the next level, made an aggregations framework out of that. So that again is supported within Lucene itself. It's a construct within Lucene that you can use. And Lucene is being used quite a lot for record linkage, classification, NLP methods. And there is another talk later today showing you how you can do some sort of it's here, right? Some sort of chemical, doing really interesting stuff with chemical data with Lucene itself. So go to that talk, see that showcase. I'll show you one small showcase now about how you can treat geospatial data for search. So the entire idea relies in this point that you can represent any geographical location using string. So this is Midtown Manhattan. And you have, if you can see that that square, it's a couple of kilometers in diameter. It has a 5-digit or 5 alphanumeric characterization that represents its location. Now, that representation is built big like that. So if that's the entire world, you'll see it's split into 32 squares. So 0, 1, 2, 3, 4, 5, 6, 7, up to Z up there, and then each square is going to be split again into 32 squares, and so on and so forth. And then New York is going to get on the 5th level this code. Now, this code, again, this square itself, I can also break it down into more, again, to 32 squares again, to get more precision. But the idea is that I just represented a geospatial location using a string, basically. And that the length of the string will give me an idea of how precise this location is. So this location code is going to be a couple of kilometers in precision. And then I can do neighbor search, because if I have a point here, for example, that point is going to share some sort of a prefix with this square, with any point that is within this square. So depending on the prefix length that those 2 points share, I know that they are close, and I know how close they really are. And I can use that for search, for aggregations, for all of that. So again, Lucene, full text search, all of this nice stuff, and also things that you wouldn't expect it to be able to search, and it's all supported natively by Lucene. So that's Lucene, the concepts around Lucene, and it's been a while. It's been around for a while, around 2010. Around 2000 actually. And so about 15 years, Lucene has been around with us. And Lucene.net is a port to .NET. So basically, it's a class-by-class port that was made by a couple of guys that wanted to have Lucene, Apache Lucene, within in the .NET ecosystem. So Apache Lucene, Java Lucene, took an estimated 136 years of effort in terms of how many lines of code, and that's taken from Olo, I think, and starting its first commit in March 2000. But you can see that for some reason, Lucene.net took an estimated 296 years to build, so more than twice the length. So question is, why is that? And as you can see, the first commit was around 2005, and actually you can see the graph here from GitHub that shows you that most activity was actually around here, and then recently we started activity again. So the reason for those skewed numbers is because of the way you would port code from Java to .NET, basically. We had one code base. It was released. I'll talk about the releases in just a bit. It was released around 2011, 2012, and that release is still the release that you will get from NuGet today. So we didn't have any new releases. Recently, when we started reporting the code, and I'll talk about that in a bit, we basically got to the point where the code base wasn't good enough. So we started moving things around, and it pretty much, just bloated the entire code base, the Git repository, and all of the stats. So what I'm trying to say here, porting code from Java to .NET is not a trivial task, and I'll talk about this in just a second. I want to show you some code first to give you an idea on how you would actually use that. So we will be looking at how to create an index, and that's using an index writer, and Lucene objects, constructs, which are documents and fields. Then we'll be looking at how to search on that index, which is using an index reader and index searcher. And then I'll briefly mention expand the analysis chain to give you an idea of how it can be used. So here is some code, and basically, whenever you get to building any Lucene type project, you'll be creating a directory. So that directory is going to have the index that you're going to use. And let me just, okay. Okay, sorry about that. Okay. So you will create a directory, and that directory is going to hold your index. So for this demo, basically, I used the RAM directory, which means my index is going to lie completely in memory. But you also have FS directory, which is what you would use to persist the index, to actually create an index, and then you can just open it later to search on it. Once you created the directory, you're going to create an analyzer. I'll explain just a second what it does. And then you're going to create an index writer to write into the index. Now, you're going to write into the index documents, and those documents will be the things that you will search on. So for example, here I indexed 3 documents, and each document represents a book. So each book I defined to have 2 fields. Now fields are parts of a document that you can actually search, or you can use it for to just contain data that you can retrieve later. So I have 2 fields, a title and an author. And then I created 3 documents and indexed them into Lucene. The way you'll do that, you'll create a document object and add fields into it. Once you're done, you'll just add this document to the index writer. Once I've done that, I will flush and commit all the data that I just indexed, because everything will be done in memory and you do need to have it persisted. Right now I'm running on memory here, but still that's something you should do, especially if you're on an FS directory. And then I'm going to search. So my directory here, my dir object variable, is going to contain the actual directory implementation, which is this is where the index lies. Once I'm ready to search on it, all I need to do is basically open it for reading. It will give me an index reader. I then create an index searcher out of it, and then I can use Lucene to define all types of queries. For example, a match all docs query, which will give me all the documents in the system, basically, or a term query, because I want to search on a term that exists in the index. Now, what you would see here, I'll run this in just a second, but you can see that I have 2 term queries which are almost identical. The only difference between the 2 term queries is an uppercase, lowercase difference, right? So the first one is going to be a fire with an uppercase. The second one is going to be fire without an uppercase, lowercase. And I'm expecting to find this document here. Now, let's run this and see what happens. Oh, it will probably open in this window, or on this screen, obviously. So I search for that, and as you can see, you have 3 searches. The first one returned 3 results, because I basically told it, please find all the documents that are in the system. So I got 3 results back, and I'm showing them here. And then looking for the term fire, uppercase or capitalized, on the title field is going to return 1 result. But looking for fire lowercase on that same field is going to return 0 results. Now the reason for this is the analysis chain. So remember I used an analyzer, I defined an analyzer back in the code. So that analyzer is a white space analyzer. Basically it will take the string, the entire string which I have here, and it will break it down on white spaces and do nothing but do this. So it will not normalize the actual tokens. So what I will end up having in the index is this token and this token. And if we go to this document, so it's going to be this token, and this token, right? So fire is going to be entered to the index with a capital F. And because of that, when I search with a term query, I will not find it. But that's exactly the point of Lucene. It can give you an actual fine-grained control of what you actually want to have done there. So you can actually tell Lucene to please search for fire, but even though the original text and the query contain that as an uppercase with an uppercase F, you will still want to find it, so you can use an analyzer that has a lowercase filter to make sure that everything is being treated properly. So that's as far as code goes. I can spend more time on that, but there's a couple of more things I want to go through. So what I didn't go through, for example, is filters and caching wrapper filter, which gives you better, powerful way of searching and keeping stuff in memory, so you don't have to access the index every time. There is NRT, which is near real-time search, and that basically gives you the ability to index stuff all the time and making sure that your index reader and index searcher always using the latest, always looking at the latest index. And for that you have something that's called Searcher Manager that helps you do that. That's some pro tips that I'm giving offhand here. When you index, you don't only put those terms in the index, you also put more stuff like positions and offsets and term vectors and all of that, and it gives you lots of control and lots of power, especially, for example, when highlighting. So let's go back to talking a bit to the meta discussion about Lucene.net. As you can see, it's quite powerful code. It's being used extensively on the JVM space, Solar, Elasticsearch, many other applications. You'll write Apache Spark, Apache Storm applications for doing classification. You'll probably use Lucene one way or another. It's a very powerful library for analyzing text, for searching, for quite about everything. It's something we really want to have on the .NET space. And as it turns out, a lot of people actually are using a release of Lucene.net that we released a couple of years ago. So we have 700,000 downloads in total, around 1,400 for version 3.0.3 that again was released on October 2012, which is quite a long time ago. And just for comparison, the current Java version of Lucene is 5.0, nearing 5.1. So we are quite behind. And again, Lucene.net is being used by many. So RavenDB, there wouldn't be RavenDB without Lucene.net because that's the indexing mechanism in RavenDB. Subtext, Umbraco, NuGet are using Lucene.net for search. Chocolatey, a lot. I know of at least 3 projects, internal projects in Microsoft that are using Lucene.net. Many other big companies. So it is being used by many. Unfortunately, while we have many users, we almost have no committers. And that's basically why the project has been stalled for many years now. That's why we didn't have a release for quite some time. So recently, I think it was around August, we got a big code contribution from Microsoft. So Microsoft contributed quite a big code base that they basically ported again, Lucene.net 4.8, which is quite recent. I think it was 1 year old. And they ported it to .NET. And porting to .NET has its challenges, right? It's not only the syntax, it's also how do you deal with various stuff, like bitwise shifts and unsigned bytes, lots of really nifty details. And aside from that code contribution from Microsoft, Lucene.net doesn't have any sponsorship whatsoever. So I personally find it quite ridiculous that so many people are using that. Some products are based on Lucene.net, and nobody finds the time, finds the resources to help out one way or another. I'll give you some way of helping out in just a bit. And it's quite frustrating because I myself do this for fun. I don't benefit from it at all. I do help some projects. I do participate in some projects, but basically I do this for fun. And products that are based on Lucene.net aren't contributing anything, and that's quite frustrating. And that relates quite directly to what we just had here in the panel. I think it's basically just because of how people in the .NET ecosystem, maybe people that have been in the .NET ecosystem for quite a bit, how they see open source in general, which is, I think, a bit different than how people in other ecosystems sometimes see open source. So today, where we are today, we have the Lucene.net 4.8.0 version almost ready to be released, at least the core component. Out of 2,000 something tests, we have only 30 left, 30 failing left that we need to fix. Once we do that, we can actually release the core and have that run for a while to have it baked, and then we can release it as a release candidate. But there are many sub-projects. So all of the analysis chain thing, all of the small stuff that I showed you, like the spatial things, the highlighters, query parsing, many other components, everything is basically its own sub-project. So some have been ported, some haven't yet. Some have been ported but without tests, so there's still more work to do there. So right now the focus is on actually getting the core ported completely, compiling, having the whole test suite running, and once we have that, we can focus on doing the same with the sub-projects. There are about 5 active contributors currently, me being one of them, and we are actually hoping to get more. And the reason for that is because Lucene.net is an Apache project. So again, it's open source under the Apache software license, and it is under the Apache umbrella. And the way the Apache Software Foundation works, it basically requires a community. And we do have a community, we don't have a big enough community right now. So everything needs to be done in a consensus. So when there is a release, we need to get 3 votes. We need to have people can veto a release. People can veto decisions. That's how projects in Apache work. And we do need people to facilitate that. So we need a bigger community. And being an open source developer is cool, right? I mean, it gives you a very good feeling. It gets you more knowledge. It gets you more skills. And it's doing good with the world, so why not? And the way that we can use your help is in various ways. If you are already a user, which is about 80% of the crowd here, so great. You can join the conversation. We have mailing lists. You can find the mailing lists in a link that I have in the next slide or the one after. Just join the conversation. Just be around. Just see what happens and participate if you feel like it. If you are feeling comfortable, take the master branch, compile it, run it, see how it goes. Just try porting your software or try using Lucene.net yourself using their most recent version. You can also help us fix some failing tests, and for that I sent a couple of days ago a mail to the mailing list with very, very specific isolated tests that you can basically fork Lucene.net, go to those tests, work only on them. It will take you a couple of hours, and then you can send us a pull request. I'll be happy to merge it in. It's basically just a no-brainer. As far as if you feel comfortable with C#, you should be able to do this quite easily, and it's quite satisfying. And if you feel like it, you can actually go ahead and help us port some more code. So basically, take Java code and port it over. If you're interested in that, contact me. I'll give you some advice on how to do this best. If you're not a user, try Lucene.net out. I just gave you an idea of what it can do. Try it out. I'm sure there is some ways in your project that you can find to use Lucene.net. Try it out. Let us know how it goes. If you find bugs, report them. If you're missing resources, ping us on the user mailing list. People are really responsive. We're really happy to have you on board in one way or another. So, as I said, Lucene.net right now is around in version 5.1, and in the 4.x versions, there has been tremendous work done. So today in Java Lucene, you have the analysis chain is really evolved. You have so many things that you have there. You have support from so many languages. You have codecs, which is an abstraction of how Lucene writes to the disk. So you can write encrypted, compressed data. You have facets, you have more highlighters than ever. You have memory index, which is a way to execute many queries on one document very fast. Lucene expressions, which is a scripting language, which is a very small subset of JavaScript that you can use when running queries, to use some sort of a scripting language when running queries, to empower searches. So many stuff has been done, and we really want to have to port this over to .NET, and we're not that far away from getting there. So plans for the future. Again, our first aim is to have a stable release really soon. So basically, the fastest we can fix those failing tests, port those sub-projects over, we'll release that. So we do need some help there. Again, there's the core project, there's a sub-project. Some .NET API refactoring will be needed to be done. So the API is very Java-esque, and we do want to have this feel more comfortable for Lucene, for .NET people. And we are nearly there. We still have a couple of things to do. We want to have the thing thoroughly tested, because Lucene.net, Java Lucene has this really novel way of testing, randomized testing. Tests are really intensive. They assure you that the library is of high quality. We want to get there as well. There's lots of other stuff we want to do. We want to support mobiles, we want to support PCL if we can do that, Azure, Async Await, and so on and so forth. Here is what you need to get involved. Lucene.NET project is, you have the link for that there. You have the links for the mailing lists. The code is on GitHub under the Apache project or the Apache user organization. And then, again, the link to the mail that I sent containing all those isolated tests that I'll be happy for you to work on. Thank you very much, and hopefully you can use Lucene.NET somewhere.